Hello, we're live. Welcome back to our live streams Beyond the Algorithm with NVIDIA. This week, we're going to be talking about our NVIDIA Agent Toolkit Hackathon, and we have a couple of guests here joining us, probably some new faces to most of you. Give them a quick run through, and then, they can talk about what it is that they're going to help you guys with today. So first, I'd like to introduce Dhruv. He's an Agentic AI and cyber solutions architect here at NVIDIA who specializes in enterprise scale Agentic AI deployment and development. And so, I think, Dhruv, this is your first time here.
Yes, it is. Good to be here. Thanks, Zach.
And next we have JB, who's a solutions architect manager. JB leads a team of solution architects who focuses on accelerated data processing, cybersecurity, and agentic AI. And finally, we have Matt, who's a senior solutions architect on the NVIDIA AI Enterprise. He's technical lead, driving innovation and performance in enterprise agentic AI and cybersecurity systems. So guys, welcome.
Thank you.
And thank you for those of you joining today from the community. Always appreciate joining on our live streams. These streams are really for you, the community, to ask questions. So please, this is an open forum to you, ask questions, and we'll kind of pause in the middle of presentations and some of the code to take your questions. So without further ado, Dhruv, I'll hand it over to you.
All right. Thank you, Zach. And again, it's good to be here. Thanks, everybody, for joining. Today, we're on the live stream, we're going to be talking about our Agent Toolkit Hackathon and hopefully give you all a lot of great resources and be able to answer your questions about building with the NVIDIA Agent Intelligence Toolkit and some of the outcomes that you can hope to see through the hackathon and at the end of it. And so, by the way of introductions, the NVIDIA Agent Intelligence Toolkit is an open source library for connecting, evaluating, profiling, and deploying enterprise-grade agents. We all know that deploying agents is hard. There are a lot of moving parts and a lot of complex pieces that are involved with deploying agents. And so we're hoping that the NVIDIA Agent Toolkit will be able to simplify some of that, reduce your time to go to production, and give you kind of full stack observability and profiler and evaluation, et cetera, along with it. And so in order of an agenda today, we have a pretty packed agenda for you. We're going to start off with Matt, who will be giving us a live code walkthrough so that everybody can understand how the agent toolkit is structured, how to build with it, maybe give you an introductory example, after which we'll open up for QA. We'll go around to our panelists here, including JB and Matt, and understand what some of the design philosophy is behind the toolkit, and what maybe some advice we have for those of you who are building with the toolkit over the next coming days. And so really excited to get started, and please feel free to post your questions in the chat, and we'll get to them through the session, as well as at points where we can stop to take questions dedicated to answering the questions you have. And so without further ado, I'm going to hand it over to Matt. Matt, live coding example, all you.
Alrighty, let me get my screen up here. Okay. Getting a little bit of a...
This is live and in person, so it's not pre-recorded.
Getting a little bit of a delay here on my side.
Bear with us.
Give me just a moment here. Dhruv, why don't you describe some of the design philosophy in parallel here?
Sure, of course. So when we built the Agent Intelligence Toolkit, there were some core pillars that we wanted to use to be able to build the library. The first, of course, is framework agnostic, which means that whether you're a developer who likes to build in LangChain or LangGraph or CrewAI or some of the other incredible frameworks for agents that exist today, we wanted you to be able to bring that to the Agent Intelligence Toolkit and build with it without too much of a difficulty in migrating that over. Second, we wanted to be able to give you full stack observability, evaluation, and profiling, which means developers want to be able to understand how their agents are doing in production. Are they accurate? Are they relevant? Their performance bottlenecks, et cetera. And so the Agent Intelligence Toolkit really helps developers understand that and see it end to end before moving to production. And finally, it is completely opt-in and extensible, which means that if there is because it's an open source SDK, if there are libraries or other tools that are not supported today and you want to extend it, it's very simple with a plugin architecture. You use what you need and only what you need, and if you need to extend it, we make that really simple too. So those are some of the core design philosophies here. I see a question from Muskan is, will there be open source frameworks from NVIDIA for building agentic systems with LLMs? JB, I'll let you take this one if you have any thoughts about that question.
You're learning about it today. So I think one thing to make clear is, right, like the Agent Intelligence Toolkit isn't trying to replace things like LangChain or Llama Index. It's a framework to build around those things. It is completely open source. And like Drew mentioned, there's composability, reusability, evaluation, profiling. It's more than just running agents. It's building, running, testing, evaluating. So you can think of it as a toolkit to help with the entire software development lifecycle of agentic AI and workflows.
And some of we'll also give you a lot of great examples and documentation. The IQ Toolkit GitHub repository has a lot of great code examples for you to get started. If you go to the hackathon website, there are a lot of great resources there, as well as the documentation, which has fantastic guides on how you evaluate an agent, how do you profile an agent, how do you extend it, and there are some great blogs that came up as well. So definitely recommend checking those out as you go through. Just as we wait for Matt to come back, we can take a look to see if there are any other questions from the community. Or in the meantime, JB, maybe I can ask you a couple questions about the Agent Intelligence Toolkit, and we could talk about why it was designed the way it was. So do you have any thoughts or ideas you want to share about what the core benefits of building with the Agent Intelligence Toolkit are, and any details you can share with everybody about building with that?
Yeah, for sure. I think, one thing that's interesting, it's like right tool for the right job. And a lot of these frameworks that you're seeing every other day, there's something new, right? There's MCP, there's A2A, there's LangChain, Crew AI. There's a ton of these frameworks, a ton of protocols. And they're all do something differently, and they all do something, perfectly, right? And so with the ability, if you're building an agentic system with the IQ Toolkit, you're not just building an agent, but you're building all of the pieces of the agents. And it was designed as sort of like software engineering first, right? Like you take your first 101 coding class and you're learning about functions, right? Like the small unit of logic when you're writing your software application. And what the team has done is they've taken that core fundamental building block and used that as the building blocks of agents with the toolkit. And so everything within the IQ Toolkit is developed as a function. So a tool call is a function. An LLM call can be a function. An agent itself could be a function. A series of agents can be a function. And so we really built it down to those key building blocks. And because there are those individual functions, we have the ability to use the best pieces of all these frameworks. So if you want to build a RAG system with Llama Index, you can build a retriever within the IQ Toolkit with Llama Index. With the composability and reusability of those functions, we're able to send that or show that RAG function to a crew of agents, maybe in Crew AI. If there's a specific tool call that you want to build in LangGraph, LangChain, you can serve that up as a function. And so it's more than just agents in these frameworks. It's these fundamental building blocks can be changed and built in these various frameworks as well.
Oh, yeah, thank you, JB. That was fantastic. I actually saw a couple questions come up as you were speaking. So if you wouldn't mind, I might ask you a couple of those as we wait for Matt. The first is, what about MCP? Do we support that with the Agent Intelligence Toolkit? And what is the extent of that support?
Yeah, so it's a function. So an MCP tool, MCP server can be a function. So within the configuration for an agent, you list out various functions, the types of functions that they may be. And one of those configurations options is an MCP client. And so you can configure these multiple tools. If you want to build your own tool in one framework, you can, locally, or if you have a tool that's remote as an MCP server, you can configure that MCP server as a tool as well. That's one side of the picture, right? The client side, but we also can serve up a workflow within the IQ Toolkit as an MCP server. And so if you have other agents or other tools that you want to connect to your workflow, you can also serve up your workflow as an MCP server as well.
That's awesome. And so I heard you mention, LangChain, LangGraph, Crew AI. What about the LLMs? Does the agent toolkit support OpenAI LLMs versus NIMs, which are NVIDIA Inference Microservices, or is there only support for one or the other?
Yeah, it's both. We have the ability to hook into OpenAI compliant APIs, and that's either running locally with the NVIDIA Inference Microservices. So there's the ability to download a model that's optimized for your hardware, whether it's running in the cloud, running on-prem, and then configure your workflow to connect to those NIMs. And it's also the ability to reach out to remote endpoints. So build.nvidia.com serves up some of these NeMo Inference Microservices for development purposes, but then you can also reach out to things like an OpenAI server, if you have an API key to connect to that.
That's awesome. Thank you for sharing. I saw another question about, can we build workflows with LangGraph just like we would, currently? And I think that's a great segue to Matt, who's back. Matt, is everything okay with the tech right now? And are you okay to share your screen?
Nothing like a live demo. I think everything is good with the tech. I turned off my blur in case that was competing for resources. So let's try this one more time. Okay, we've already made it further than the last time. This is a good sign.
That's great.
Okay, if someone could just let me know that they're seeing my screen, that'll be good, and then I'll get going.
Just got to share it. I think you're up.
Yep, you're all set.
All right, perfect. So what we're going to do here is we're just going to take a look at how to use the toolkit. And I'm going to come at this from the perspective of a LangChain developer. Many folks might have some code that they already have implemented, or maybe you're familiar with the LLM framework already. This is a common entry point. You probably have some scripts like this sitting around. This script in particular was derived from the LangChain documentation, kind of the onboarding to agents. So what we're going to do is we're going to walk through this here really quickly and then see what the process looks like in order to bring this into the AIQ programming model. So what we've got here is okay. So what we've got here is some standard imports, and we have a internet search, right? This Tavily internet search. This is a common tool that folks might use in order to provide their agent with information that would only be accessible by querying the internet. Right? And since we're talking about agents typically have a set of tools, and those tools are used in order to basically solve problems as the agent reasons through it. Right? So we're going to create a list of these. Right now, our list of tools is of size 1. The next piece that we're going to do is create a LLM client. Right? So this LLM client is going to be kind of the main reasoning brain behind our problem here, and we're going to use here llama instruct model in order to do that. Then as we scroll down, we're just going to use an open source prompt, instantiate a React agent. You see we're going to pass in the tools and our LLM and this prompt. Then we're going to instantiate an agent executor. This agent executor is basically going to create a loop for which we kind of a reasoning loop. And then towards the bottom, we're going to invoke it with a simple prompt here, and then take a look at the output. So we should be able to run this as is. Right, and then we're going to see what it looks like to bring this into the toolkit. Okay, so here it heads into the loop. It's going to go ahead and call this tool that we want, and it's going to give us the answer. This is great. So what we're going to do at this point is I'm going to use some of our command line utilities in order to build some scaffolding. So what I'm going to do here is I'm going to create just a sample library configuration set or some scaffolding, and then we'll talk about why I'm doing that once I have this thing built. Okay, this looks good to me. So what this is going to do is it's going to, in my temporary folder, it's going to create basically some scaffolding. Since every toolkit plugin is effectively a library, what this does is this creates a simple Python library for us with some setup pieces here, like this PyProject TOML file. And what we'll notice is this looks, pretty standard. We're bringing in some toolkit dependencies here, but I'll have folks pay special attention to this section here. what this is basically doing is it's saying, okay, well, we're going to be implementing some things within this, Python package, and in that Python package is going to include some toolkit plugins, and the plugins are going to be found in this register.py file. Right, so this is going to be contained in our source directory. This is very key. So everything that we're going to do here is going to be registered as a plugin. Right, so we're going to take a quick look at that, and that's going to be this here. Right, so we have this AIQ or this toolkit registered function that's implemented and imported here. Because it's imported here, it then gets picked up by our plugin hooks here. So that's important. This is all created for us. So I'm going to go ahead and close out of this. And the next thing I'm going to do is take a look at this actual registered function. All right, so this registered function, if I can get this thing over here on the side, is going to be the common kind of developer interface that you're going to be working within. Right, so this top section here is a basically a named Pydantic model. Pydantic models are really good at enforcing types. And we're going to use this in order to define some runtime parameters for this registered function and give it a name so that we can look it up from the toolkit's kind of local registry. Right? And we're able to, this is important because every function or every agentic workflow is built up from a YAML configuration file where we're looking up things by names. And we're going to take a look at a configuration file here really shortly. Actually, matter of fact, let's take a look at one right now. All right, so this is a very small and simple one. Right, so this workflow here is going to actually map to this registered function that we have implemented here. And that's all built kind of default by the scaffolding. And you'll see that this name maps to this name here. Right? This is looking this thing up because this plugin is registered locally and it has exactly one parameter, which is largely meaningless right now. And it's paired up with this registered function where we pass in this configuration object. Right? This is how this thing gets registered. We're actually going to extend this here really quickly. And we're going to include, I'm going to make this a little bit wider here so we can see it. This section called framework wrappers. We heard Dhruv talk about profiling. This is how we're going to enable profiling. Right? We're going to be implementing this in LangChain. So we're going to add these framework wrappers that focus on LangChain so that we can profile this thing. So I have to do one more import to get this. All right. So I have that. The next section here is kind of the main, the function implementation. Typically, you'll implement a bunch of setup code here. And then in here, you'll put, whenever a message shows up, what you want to actually be done. And then at the end, we yield this intermediate function info object. This lets us construct these functions and wrap them at runtime in, let's say, a Llama index or a LangChain or a semantic kernel, or pick your favorite framework. This is great because I can build this plugin and I can release it to the developer ecosystem, which includes more than just LangChain developers, right? People who are more than LangChain developers can take advantages of this in the end, and then some cleanup, right, at the end. So that's the main setup. So here, what's going to happen by default is just this hello world type of output. And we're going to now bring in our LangChain example into this. And we're going to start doing it in kind of a naive way. The toolkit is very opt-in. And I'm actually going to make this just a little bit smaller for just a moment, and just bear with me while I do that. All right, so we're going to start by opting into very little. All right, so I'm going to take my setup code, which is going to come all the way through here. All right, and I'm just going to take this wholesale, and I'm just going to paste it right here. And then I'm going to, oops, accidentally do this. All right, I'm going to tab this over.
So Matt, you're just taking your LangChain code, straight LangChain, and then copying it right into the IQ Toolkit framework. Right?
Bingo.
Right?
That's exactly what I'm doing, right? So this is typically the first thing folks will do when onboarding is they'll take their code, they'll move it over. They may not opt into everything, right? And they'll just get it going to start. And this is typically what I recommend for folks, right? Let's just bring in your code here. Let's get it working, and then let's think about ways for which we can start to optimize this. So one thing I'll just pause on here and address is the toolkit is async first. And the reason for this is, we spend a lot of time waiting for responses to come back from a large language model, right? So if I can, instead of doing things synchronous, I can do things async. I can have a lot more messages in flight, and I can have a higher throughput for this microservice that I bring up. It's all based on this toolkit implementation here. So you'll see things like await, and you'll see things like async all over the place. And the reason for that is because we're async first. We do that for performance reasons. Okay, changes to a return.
Matt, would you mind if I ask a question?
Please.
I know you talked about async and performance, so I was wondering, you said the agent toolkit is able to track, my link chain because I decorated with a framework wrapper. Does that make my agent slower, or is that async as well?
Everything's async. So there's very little overhead here when running this. The overhead that you'll notice is, there's a little bit of overhead when we bring up the microservice. But that's true for just about every microservice. Everything is async and non-blocking. So the overhead that you'll see is negligible. But the overhead that you will notice is that we did have to take our code and kind of put it into the programming model. But as we can see here, that lift is actually quite light. So we should, at this point, have our code completely ported over to the toolkit. And I can now, oh, go ahead, Drew, were you going to say something?
Just a really quick follow-up as well. We see a question on the screen about LangGraph. So if I had a LangGraph agent, would I still just be able to copy paste and do exactly what you're doing right now, or would that look different for me?
Yeah, the process would be identical. The only difference is you'd be defining your graph instead of using the kind of bare bones LangChain interface. Yeah.
Awesome, thank you.
You bet. Okay, let's see. We're going to get this served up here. Okay, so what I'm going to do now is I'm going to bring up a microservice for this new toolkit application. And it's going to give us the same functionality that we had on the left here, but instead, what it's going to do is give us a microservice using all of our toolkit goodness. So when this comes up, probably now make this a little bit bigger for folks. So we now have a microservice running on port 8000. And what I can do is I can go ahead and test it, right? So that's exactly what we're going to do here. Right? And I'll ask it the same, for fairness, I'll ask it the same exact question we asked it in our standalone example. Let's try this out. What is the current weather in Santa Clara? And go ahead and run this. Right, and we can see that this is being invoked. But the key difference here is we're using the Toolkit's Fast API front-end plugin in order to bring up a microservice, and we're handling everything async on the way in. So we can actually, you can imagine this being the entry point to your container, maybe running in some kind of Kubernetes cluster, right? You can see here that it made an internet search and it gave us a response, and that's indicative of it using the tool that was kind of called as it's, and we saw that output as it was scrolling through. But we can do a little bit better. So let's get rid of this for a second, and let's talk about opting in, right? So we have a number of things that we might want to do. One of those things that we might want to do is add some parameters here, right? This is a very standalone function that I can't use with anything else, right? So let's actually make these parameters meaningful. So the first thing I'm going to do is add tool names, right? Oh, that's really nice. Kind of gave me everything. Tool names is important because if I wanted to use this agent with some other set of tools that are more than internet search, I should be able to do that, right? I would want to be able to configure that from my YAML file, right? So that's kind of what we did here. LLM name is going to give us, let's say we didn't want to use that Llama model. Let's say we wanted to use a 3.1 model, or a smaller model, or an OpenAI model, or something else, right? We want to make that configurable. Let's say we wanted to pass in history, historical information like chat history, or we wanted to change the iterations of our agent executor, so on and so forth, right? Change the description of what this thing is capable of doing in case another agent wants to call this as a tool, right? So what we're doing here is we're adding in this configurability. I see a few squigglies though, and we're going to go ahead and, go ahead.
Matt, really quick, a question just before we move on. There was a question from a user about a combination of different techniques. For example, other machine learning, NIMs, other kinds of LLM, maybe SQL as part of an agent. So if, for example, a developer were to build the code to support that, would those also be configurable using the config object? And would the IQ toolkit support that?
Yes. So this is an extremely flexible data structure. So if you can effectively define it in a Pydantic model, you can use it to configure. And because each of these functions is a black box, you can put whatever you want in here, right? I could put a SQL agent in here. I can name a standalone SQL agent here and have this whole thing be very SQL oriented. And then I can just call it as long as it's been configured, and I can use that in any kind of tool calling or just directly invoking scenario. So I think the answer is yes, Drew. That type of thing would be supported, and it wouldn't be too hard.
Thank you.
You bet. Okay, so now that we've updated our configuration object, let's maybe see if we can update our configuration file. So if I'm going to pass in a tool name, I need to have that tool defined. So conveniently, there actually is a Tavily tool built into the library. So let's go ahead and use one of our other command line utilities. All right, so what we're using here is, after a while, you're gonna have a lot of registered components or plugins, and it can be really helpful to see what you have and how to configure those. So here I did just a quick search to see if we had another tool that we could use, and as it turns out, we do. All right, so what I'm going to do is I'm going to amend our configuration file with a new tool that has a name. And
so, Matt, as you fill this out, why did we use Tavily here? And if I wanted to switch to something like DuckDuckGo, would the lift to include a tool like that be significant?
I'm sorry, what was the tool that you'd be considering to?
For example, if we wanted to use DuckDuckGo search instead of Tavily, would I be able to write a function to do that and import it just like you are right now?
The process would be identical. The only difference here is if that tool didn't exist, you'd have to create something that looks a lot like what we have on the right, so that I can refer to it by name. The name would be here, and then the process would be the same. So you very much could do something like that. In fact, we've designed the toolkit to support that use case and many others like it. Hopefully that answers the question.
That was great. Thank you.
You bet. Okay. So we're going to pass in one tool name, right? We have one function defined, and we're going to use, let's just do this, my internet. Gosh. Okay. The reason I'm naming this different is just to show that I could have multiple instantiations of the same underlying tool type, and you want to refer to it by this name. So that's what I'm doing here. We don't yet have an LLM defined. So what I'm going to do is do that right now in this LLM section.
So you must have like a huge GPU running this LLM on your machine, or how are you connecting to these?
I'm connecting to these through the build.nvidia.com. And so this actually, the toolkit does not require a GPU at all. So the system I'm running this on doesn't have a GPU. So that's really great. All of the GPU computations are happening remotely, and it's through build.
And Matt, in the demo that where you ran the agent just now before looking at the config, was the search also Tavily? Was the same tool you were talking about?
Identical. Yep. We found that tool was so useful that we kind of created a pre-wrapped plugin so that others could take advantage of it. In fact, we looked at the LangChain docs when doing that. We used the LangChain Tavily search inside of this black box wrapped tool. The key difference is it's very easy to use this with any other framework as well. So hopefully that answers that question. So what I've done here now is I've added a LLM that can be used, right? Configurable. I could have many different LLMs in this section. I've defined a function, right, that can be called as a tool. And I'm going to pass that function in, or that registered function here as a tool to our React agent to try to make this thing a little bit more flexible. I'm now going to use the name, the runtime name of this LLM here. And I'm going to change this up just a little bit because the prediction was not quite right. And I'm going to validate this against my configuration object. So I have tool names, LLM name, max history in there, okay. The rest of these have default values. I don't have a description. Not that anything else is using this, so it's going to use this default, so that's probably fine. And I think that will do it as far as configuration is set. So now let's change our implementation, take advantage of some of these. But before I go too far, I'm using a couple data types that you may not be familiar with. So this function ref and LLM ref are designed so that you can have tools or registered functions call other registered functions. And when doing this, you know, what's kind of implied there is we've got, you know, this nested structure. And what these basically do is ensure that all things get brought up in the right dependency order so that you can have these really fancy hierarchical agents or tool calling scenarios. So if you're doing something like that, it's great to use this function ref or LLM ref for any of our plugin types. And that's what we're doing here. They're effectively treated like a string with some additional enhancements in order to support that runtime dependency graph building. Okay, so now it's worth talking about this config and this builder. Right, we didn't talk about those before because we weren't using them. But now what we can do is we can reference anything that's defined in our configuration object through this variable. And we can use, you know, a lot of this information to instantiate LLM clients and tools and registered functions with their runtime settings. And that's exactly what we're going to do in order to make this more flexible. So we're going to go ahead and start with this section. All right. So we're going to do this, tools equals builder dot get tools. Okay. So what this is going to do is it's going to look at our configuration object that is populated with the settings here and give me an instance of all the tools that are defined and then wrap them in LangChain, which basically gives me this line here in a single shot in a much more flexible way. Okay, so that's what we've done.
So
now,
sorry, Matt, if my developer, if another developer had written their tool in Llama Index, could I still import it as a LangChain tool? Because I'm working with LangChain?
Yes. So if they had implemented something in Llama Index, I would instead do this. Well, so you would have no idea what's in that black box, number one. And if you're working in LangChain, it would look just like this. So you would have, that would be completely transparent. If you instead wanted to work in Llama Index, it would look like this, right? So you'd be able to mix and match very easily in a scenario like that. Drew, did that answer the question?
Yes, thank you.
You bet. So the next thing we're going to do is we're going to get rid of this, and we're instead going to construct a LLM at runtime. Okay, we're going to pull in our LLM name, and we're going to create a LangChain wrapped LLM client, which is really great. We haven't changed anything else except made that a little bit more flexible. So now I could add a whole bunch of other different types of LLMs, give them a different runtime instance name, and pass that in here. right? And now my registered function would be, flexible in order to support those different scenarios. All right. So the next thing we're going to do is we're going to bring in some of our configuration settings here. Right? So I'm going to do this now. Right. So now you can change the settings of your agent executor from YAML at this point. Right? We've pulled those things in. And then the rest of this should be the same. All right, so let's go ahead and run this again. And if I haven't completely broken this, it should come up. Okay, so now let's bring this up again. All right, just a really convenient way to test your API. Okay, we see our new tool being invoked by the name that we've defined in our YAML, and we go ahead and get an answer. Right, so that's great. It's the same functionality, but now the difference is it's something I can share with my team. Right, so if I find that this agent, this general agent, would be applicable to other developers I'm working with, I can now give them this Python package. And if they have the toolkit installed, all they have to do is pip install it, and they can see this tool by name, right? Or they can reference this tool by name in their YAML configuration. They can search for it, very similar how we search for the Tavily tool, and they can start to configure it and use it in their application.
Matt, if I had tools with similar names, how can I differentiate these different tools, or how can the agent differentiate between different tools? Is there a place I can provide a description or something similar?
Yes. So I might take this question in a few different directions because it's a good one. So these types are namespaced, right? So if you have collisions in this name and across different packages, you would just add the package name in front, and that would handle the collisions. So that's one way you could do it. Let's see, what's another way to, so if I wanted to use this agent in, let's see, in several scenarios, let me make this a little wider, right? I could actually, what I could do is I could say, okay, oops, this is getting overly liberal with its corrections. What I could do is say my agent 1, and I'm using this same underlying type, and I could say my agent 2. Right, so this is the reason for the flexibility. And I could say, let's say, another tool. Right, so this other tool would have to be defined above in this function section. But you can use the same underlying type many times, give it different runtime settings, and you could actually call these from other functions or from this top level tool. Right, so like another tool, my agent 2.
So you're showing basically right now like a multi-agent system. You're having an agent that has access to multiple agents and that can choose based on the description.
Precisely.
Awesome.
Right, so I'm gonna go ahead and delete. Oh, go ahead, JD, please.
I was just going to say, and that's, I mean, that was just, you already have one agent configured and you're just adding, you already have the one agent coded up, and then you're just adding it into the configuration file. And now you're getting this multi-agent system. There's no extra coding needed on this example.
That's right. And I think that's, a lot of the beauty of the way we've designed this toolkit is to minimize the amount of redundant code that you would have to write in order to basically design, up to a multi-agent system. Right? We use the same underlying agent implementation, but because we made it more flexible, right, we could pass in a list of tools to it give it a different description, and now it's a completely different tool, right? And that's super powerful. So it was a really astute observation, JB. So another thing I wanted to show here really quickly is I can use this command line utility. What did we call this? My React agent. Right, so if I shared this with my colleague and they pip installed it, right, they now have access to this on their system. In the same way we figured out how to configure our Tavily internet search, they can figure out how to configure their React agent, right? Oh, tool names, LLM name, all so on and so forth, right? As well as the default values. So that's really the beauty of the plugin system there. So we're going to do one last enhancement to this. And I'm going to show you how to use this with our open source UI. And I do have a cheat sheet here for time, and I'm going to pull this one in because it's a little bit different. Oops. Okay, so I'm going to comment this out. And I'm going to put this in. I'm going to need to do a few additional imports here to support this. What I'm going to do is I'm going to use one of the built-in, some of the built-in objects from the toolkit, in particular, these OpenAI spec data models, right, so that I can expose an OpenAI compliant microservice from the toolkit. And that's what we're going to do here. So we're going to use this different type. And this different type also lets us pass in message history, right? So I can support things like multi-turn, and our UI can provide that information. So I'm choosing to use this now just to support that for a broader use case. Then I just wanted to show you using that with the UI. So we've added a few different imports, right? So those two data models, and then this lang chain trim messages so that I can extract the message history. Right, so I've imported those. And within here, I'm gonna go ahead and do a few things slightly different. Oops. Let's see. Just bear with me on the auto completions.
Matt, as you type this, I might just take a question that we have from the audience, and I can answer this as you type so I don't distract you. But the question is, how can I integrate an existing agent framework that I'm using without LangChain? Do I have to redo everything with LangChain? And the answer is no, you don't have to redo everything with LangChain. The IQ toolkit is framework agnostic, which means you can build a LangChain, you can build a Llama index, Crew AI, et cetera. Those are things we support out of the box, including semantic kernel. But if there is another agent framework that you want to bring to the agent intelligence toolkit, what you can do is either just bring it in wholesale as a copy paste, just like Matt did in the earlier demo, or if you want to actually extend the toolkit to support another framework that you may be using. We actually have a great blog about that as well recently, where we extended it with the Agno framework, and we can share that with you in the chat as well as on the Discord, so you can understand how to extend the toolkit further. Go ahead, Matt, back to you.
Thank you. Oops. So what I'm showing here is, we now have a different data structure, and if you've spent much time looking at the OpenAI spec, you'll notice that this looks pretty familiar. So I'm actually what I'm gonna do now is I'm gonna look at port 3000, which I have the UI on, and I'm gonna ask it the same question. What's the current? Right, so this will do the same thing, but using our UI now, right? So we have a UI that's up, that's communicating with our microservice using, that's OpenAI spec compliant, and it gives us the same kind of answer. So this is actually pretty cool, right? So now we brought in the UI. You don't have to use this UI, but it's included in the external section of the library. So you're welcome to use that or extend it, or bring your own UI. So what I'm going to do now is I'm actually going to say, okay, there's a much fancier use case that we can do. Right, there's a much fancier one that we can do. So I'm going to get rid of all of this, and I'm going to now open up this pre-built demo that we have. This pre-built demo is a much more complicated YAML file. Here we have many different LLMs. We have two, one that's using a NIM and one that's using OpenAI. We have an embedding model that's a NIM. And we have a number of different functions here. So here I have some in-memory retriever setup that are hosting vector databases for a fictitious company called GPU Experts Incorporated with various, HR policies, dress code, payroll, PTO. I've given it a bunch of simple math tools. I've used the built-in React agent to the toolkit, right? So one that we didn't implement, and we've given it access to the math tools and the multiple RAGs. These RAGs are actually implemented in Llama Index, right? And then so now we have two agents as functions or tools. And then we're going to use our kind of user-defined agent, and we're going to pass it two different agents, and then kind of a notional date time tool that we have defined above. And I can now bring this up in the very same way, right? This plugin lets me use others' work. And we're getting pretty close to the last section of the live coding here. I can now bring this up in the same way.
And so Matt mentioned the pre-built agents. There's a handful of those that we have. So there's the React agent, there's a straight tool calling agent, there's a reasoning agent built into the toolkit that uses a reasoning model to create a plan. So you can have complex agentic systems like Matt's showing and wrap them around with a reasoning model as well. And those pre-built agents, right, they're implemented within the toolkit in a specific framework, and then you can bring your other functions and tools in other frameworks as well, and they'll work just flawlessly because of how we have that interoperability between frameworks.
Thanks, JD. So what I did, folks, I don't know if you saw, it was pretty fast, and it's kind of hard to see here in this kind of limited UI, but to keep everything together, I'm using it, is this chat history. So I'm turning this on so that I can take advantage of that new data structure that we're using. I now have spun up that additional, more advanced multi-agent that's going to be performing RAG and a number of other things. And I'm going to ask it a question. I'm going to tell it I'm a new employee at GPU Experts Incorporated. Right, so it's just going to notionally respond to us. The NIMs might be a little bit overloaded on the build right now, so we'll just bear with this for just a moment. And while that runs, I'm going to explain a few things, right? So we'll notice that we're using this description field in order to give this agent, give a tool calling agent information about what this agent is capable of. So we've used this generic React agent. We've given it a series of tools. So this description lets us know what this tool is capable of, and we follow that pattern kind of throughout each of these, right? So we're now using these in those scenarios. So it's given us a little bit of information, drilling in on some of those RAG systems. Let me just ask it a specific question about dress code. Please tell me about the dress code. Right, so what this is going to do is it's going to invoke our multi-RAG agent. It's using that description in order to identify that it needs to use that. It's going to give us the response at some point here.
Matt, how does it handle UI interactions? Is there a connection between the open source UI and the toolkit library?
So the UI is a separate submodule, right? So it's a submodule within the toolkit library. So if you go to GitHub and you take a look at the library setup, you'll see this external folder, right? So I've cloned the GitHub repo, and you'll see that this AIQ toolkit UI will be in there, and that's its own GitHub project. And you can navigate to that, and that's actually what I'm using here to bring this up. So it's a separate project, but we include it because it's really nice to be able to hook up a UI to this and give folks a starting point. So that's what we did here. And then the last piece I'm going to show before we stop here is how I can spin this up as an MCP server. So I think I heard a question about MCP earlier. So if I wanted to do this instead as MCP.
And Matt, really quick, I might answer a question while you type this out. There was a question about if we're using short-term memory to combine previous interactions. Correct me if I'm wrong, but I believe how this has been implemented is the chat history is stored as a list inside your function, right? And so every time you have a new chat come in, it's appended to your list of interactions and then sent into your agent. However, the Agent Intelligence Toolkit does support long and short-term memory as a module, including support for hosted SaaS type memory providers such as Zep or Menzero. Does that sound about right to you, Matt?
That's well said. Yes, there's great degree of flexibility. The way that the UI kind of supports sending messages to the running workflow is through that OpenAI schema and the list there, which is what we were taking advantage of, if we recall the data structure in the workflow. But yes, just as you said, Drew, we do support those memory structures. Okay, so it was really easy to bring up a microservice, fast API microservice to be specific, what we did before. So what we're going to do now is we're just going to create an MCP server. That's what we did on the left. So I used the AIQ MCP command instead of AIQ serve, and that brought up our entire workflow as an MCP server. Right. So if I can run this and I can take a look at all of the tools, all of the MCP servers that are tools that are available via that server that we just brought up. And we can see that everything in our configuration files now in MCP can be accessed as an MCP server. Right. So I just wanted to show the flexibility with just a different launch configuration or launch settings that we now can support building MCP servers. We can also connect to MCP tools from MCP servers, right? So we can basically have functions here serving as MCP clients and fold those in just as trivially. So I think that concludes this section of the live coding example. Hopefully this was a pretty quick onboarding, right? So just to summarize, we showed you how to bring in a simple LangChain React agent wholesale without opting into the rest of the toolkit. We then showed how to take that and then opt in to make that more flexible. And then we showed how to bring that into a separately defined workflow and then use that in a much fancier multi-agent setup, and took advantage of this plugin system to do so. So anyway, that's what I wanted to share, and I might hand it back to you, Drew.
This was awesome, Matt. Thank you. It's the best onboarding I've ever had. But so really quick, I'm going to come back to you all in a couple minutes to ask you about maybe what you'd like to see out of the hackathon, and if you have any sage words of advice for the people who are participating. But in the meantime, if I could share my screen really quick, I just wanted to give folks a really quick introduction into some of the resources they have to run compute. Like Matt said, and I'll wait until you stop sharing that, but like Matt said, the Agent Intelligence Toolkit is an incredibly light library, which means that you don't need a GPU to actually run the library. You can run it. I run it all the time on my MacBook without a GPU on it, and so you don't really need it to run the Agent Intelligence Toolkit. But the question then becomes, where do I put or host my LLMs? Is there a place I can run my large language models to run my agents? And one of the resources that we provide is it's called build.nvidia.com. If you go to build.nvidia.com and you sign in and you create an account, you're able to look at any of these NIMs or NVIDIA inference microservices to be able to run large language models. So you can click on any one, for example, our newly released Llama 3.3 Nemotron. And if I wanted to use it, all I need to do is create an API key. By default, there are no limited number of credits that you get, but you are rate limited to about, I believe, 40 requests a minute with this. And what you can do is create an API key, use it just like Matt did, where you export it in your environment variable with a config, and that way you can use an LLM without having to host it on your GPU. So that is a resource that you have, as well as, of course, being able to run the toolkit without a GPU on a very light library. So I just wanted to stop sharing, share that with you before I stop sharing. But I'm going to come back to JB. JB, what would you love to see out of the hackathon, and do you have any advice for the participants?
Yeah, I think, I kind of hinted at it before when Matt was showing off his thing. I think multi-agents is super powerful, and seeing like a team of agents working together, each handling their own specific tasks, is really interesting. And so there are some examples in the GitHub, and one of those is an alert triage agent. It's built with LangGraph, so I know there's some questions about LangGraph. And the alert triage agent kind of takes alerts come from various servers or networking equipment, and basically inspects the alert, tries to remediate some of the issues, grabs information from a server. Is the network port down? Is there an issue in system logs? And provide an information to the user. And so there's a ton of these examples within the GitHub repo. As simple as a simple RAG, a simple calculator using some of those pre-built tools, and then also more multi-agent complex scenarios. And so for me, I'm interested in seeing these wide range of teams of agents all interacting to solve a common goal.
Oh, that's really cool, and I'm also really excited to see that. Really quick before I come to you, Matt, there was a question about submissions per person, and just wanted to clarify that if you are participating in the hackathon, you are limited to one team, one submission, right? So you can't submit multiple entries. It is one submission per person. Okay, Matt, over to you. Do you have anything you'd love to see out of the hackathon, and any words of advice for the people participating?
Yeah, so I really like to see folks lean into the plugin system. So I would encourage folks to have a look at the built-in functions that we have. Look at the sub packages that we have, and if you have a use case that you don't have, that we're not necessarily supporting your needs, consider extending it, right? And consider extending it in a way that your other developers could take advantage of. Your other developers are the world of developers, right? Because this is an open source project and very community driven. And a lot of its power comes from being able to provide others with reusable tools. So I would think about that, but I wouldn't you don't always necessarily need to start there. I always typically suggest folks just get started, and it's okay, as your first agent to just drop in your monolithic agent, right? I see tons of folks who get started with the toolkit, just doing what I did in the first example there. Like, okay, let's get the mechanics together. Let's learn the programming model, right? Let's learn this, register function syntax. You're going to see it over and over and over again. And then, right, once you got that going, you say, okay, now I'll put my generalization hat on, and now, what's the plugin look like, right? What would I want, right, my colleague to give me so that I could sit on their shoulders? So that's kind of, I think, what I'd like to see out of this hackathon. I want to see the community come together.
That's incredible. Absolutely, couldn't agree more. I did see a great question about how token consumption and token efficiency impacts agents, and I think that's a great segue maybe into what I was going to mention. Is I would also love to see the community rally around evaluation with agents, so understanding how these agents work. If they have data sets they can test them against, we'd love to see the community either build custom evaluators and upstream them, or come up with really interesting ways to evaluate agents that are in production, understand their token efficiency, et cetera, and make use of that harness as well as you build the agents. And hopefully that will accelerate your development trajectory through this hackathon. So that's one of the things that we'd love to see as well. I know we're coming up on time, and so I saw a question about office hours. I think we'll mention that right now. We will have office hours. We'll have 2 more office hours coming up. The first on May 15th at 9 a.m. In the Discord, and then the second on the May 21st, also at 9 a.m. both Pacific time. And so if you have other questions that you'd want to talk to us or other folks at NVIDIA about as you go through this hackathon, please feel free to come to those office hours and ask your questions, and we'll do our best to get to them. But that's all we had for today. Please feel free to check out the Discord. Please feel free to check out all the amazing resources we sent you, including the GitHub. And we're really looking forward and excited to see what you build. JB, Matt, Zach, and everybody else, thank you very much for your time. To our audience, thank you for attending and taking the time out of your day to watch. And yeah, good luck, everybody. And hopefully we'll see you on the Discord.
Thanks, everyone.
Thanks, Drew. Thanks, all.
Thank you guys for joining. See you in our next live stream.
Take care.